You're never too old to have a favourite prism, and this is mine. This is the circular prism, also known as a cylinder or a tube or a tin can. And as you know, the volume of any prism is the cross-sectional area times the length. So we work out this area. Now if we slice a prism, we're still going to have the same area. That's the magic of a prism. It is the same cross-sectional area all the way along. So if we want to find out the volume of this cylinder, we take the circle area, which is this here, as you know is pi r squared, and then we times it by length. Volume equals pi r squared times L for length. The simplest prism is actually a cuboid. Looks like a bit of a shoebox really. But if you imagine just given the 3 dimensions of a cuboid, then the volume is width times height times length. But as you can see here, the height times the width is actually also the cross-sectional area. So volume is width times height times length, or cross-sectional area times length. These are the common prisms used in GCSE exams. This one, obviously, we've just looked at. This is the circular prism, aka the cylinder, and the volume is pi r squared times length. This is the triangular prism. I'm tempted to call it a Toblerone, but as you know, Toblerone is full of slices. But anyway, it's sort of a Toblerone anyway. Triangular prism. The formula for the area of a triangle is half base times height. So the volume is a half base times height times length. And we've just seen here, this is the rectangular prism, aka cuboid. And here the volume is width times height times length. So let's take an example. Here is a circular prism with diameter 8 centimeters and length 12 centimeters. Work out the volume of the prism. Give your answer in terms of pi. Well, at least pi takes out one of the complications. Let's have a little think. We are going to work out the volume, and that's equal to area times length, and the area is pi r squared. And just for me, because I have in the past made this mistake, I'm going to concentrate on whether it's radius or diameter. We have been given the diameter and we need the radius. So radius equals half the diameter equals 4. The area of the cross section is pi r squared. R squared is 4 squared is 16, so that's 16 pi. And now the volume is 16 pi times length, and the length is 12. So that's equal to 192 times pi. Wouldn't do that in my head if I had the opportunity of using a calculator. Obviously, we're not here for show. We're here to get the answer right. Now, obviously, the question's never finished without a check. Bit of a tricky one. This is only one way to do it, really. So let's eyeball the calculations. R4, check the diameter, area, pi r squared. Yes, that's okay. Very happy with that. So what did we do? We had a think. We took a moment. We took a breath. Volume is area times length. We then did the calculation. Then we eyeballed it and checked it. Here's a slightly different question. Little bit harder. You might think of it as a slab of cheese, but it's a triangular prism. Let's see how we get on with this one. Obviously, volume equals area times length, and the area, now it's a triangle here, is half base times height. But we're not given the base. We don't know what this is. So we have to find it. And because this is a right-angled triangle, we're going to use my old friend Pythagoras. That's the hypotenuse. This is the base. So we know 3.2 plus b squared equals the hypotenuse squared, 5.5 squared. Subtract 3.2 squared from both sides. B squared equals 5.5 squared minus 3.2 squared. B squared equals 20.01. Interesting number. Square root that. Slightly ugly number. B is equal to 4.47 and the bits. So now let's go back to calculating the area. Area is a half base times height, which comes out at 7.1572. I use a lot of decimal places here, where the answer's got to be to 3 significant figures. So I normally hold this in the calculator, to be honest, but I'll just show those figures. Volume equals area times length. This is the area, and the length is given in the question 17, so that's 7.1572 times 17, 121.67, which to 3 significant figures is 122, rounding up a little bit there. Right. No answer is complete without a check. So let's eyeball the calculations. Volume equals area times length. We need to get B half. Remember our half. Base times height. Yeah, multiply by 17. All looks good. I always check Pythagoras. Let's just work it back the other way. So we've got 4.47 squared equals 3.2 squared, and that is equal to 5.5 squared. The hypotenuse. Yep, that works. Give myself a little dollop of dopamine and think about what we did. We had to think about it. We realized we didn't have the base, so we had to do a calculation, which is by Pythagoras, which gives us an extra mark or so, I would expect. And then we did the calculation and then we checked it. What goes wrong? I love finding out what goes wrong, because I haven't, I'll say in the past, but I occasionally do it now. I occasionally make a few errors with the circular prisms. First of all, I don't do this one. I don't use 2 pi r for the area. Nope, I use pi r squared. Well, I've got that one. But I do this one. I sometimes forget, if they're a bit tricky and give us the diameter, I forget to halve it and use the radius, which can cause problems later on. Normally I check it and get it right, but that's one of my favourite errors. So solution, check it's the radius. Sounds about common sense really, doesn't it? What goes wrong with triangular prisms? Well, we know the formula here. Sometimes people calculate in error. They forget the half. It's one of those strange things that you give someone a triangle and they will calculate the area very easily. You add it to a prism, and that extra bit of work makes them go a little bit hazy and they forget this half. So don't forget your half. The solution, remember to multiply by half. No secret there. And bad Pythagoras as well. Again, simply because it's a prism, adds a little bit of complexity. So mark the hypotenuse with H. Be very careful when you use Pythagoras. Right. And there's the Pythagoras formula. Here's a method hack. There's a prism. Let's find the volume. The method is, forget it's a prism. Focus on the area. Always work out this area first. And then you'll see the old pattern. So you'll see the pattern of a half base times height. You won't put on times length and then forget about the half. Or remember to use the radius. It's always easy if you focus on small parts of the question. Focus on getting the area. Area is going to equal x, y, z or something or other. And then volume equals area times length. I hope that will make a tricky question a little bit easier. Don't forget to subscribe. We have got lots of videos coming soon, certainly coming before your exam. Subscribe and hopefully this will make your exam a little bit easier when you do a resit in November. Best of luck.